we will continue to solve examples of homogeneous differential equations. Okay, let's continue with this example. Okay, the first order differential equation is given as x times sine y over x dy over dx is equal to y times sine y over x plus x. To see that this equation is homogeneous, we divide by x, then divide everywhere by x. What we get is, we get the x cancel, dy over dx, y over x sine y over x plus x over x, so we know this is equal to 1. Okay, I will write plus 1. So now we see that it is homogeneous. Now what we do, when we see homogeneous, we will let y over x to be u, so we will substitute. Then y is equal to x times u. So when we take the derivative, we need to take the derivative of the product. So what is the derivative of x? It is 1 times u plus x times u prime. X times u prime. So in the equation, we will substitute in the equation. When we see y over x, we will put u. When we see y prime or dy over dx, we will put, so this is, we know, dy over dx. So we will put u plus x times u prime. Okay, let's do this. In the equation, let's do this. So we have sine u times dy dx, so we will put u plus x u prime. Y over x is u times sine u plus 1. So to see that this is separable, also divide everywhere with sine u. So divide by sine u. So both sides. So we have u x prime u is u sine u over u, sine u plus 1 over sine u. So these will cancel. We have u plus x u prime is equal to u plus 1 over sine u. And we can cancel these u's also. So what we are left with, x u prime is equal to 1 over sine u, or we can write x du over dx is equal to 1 over sine u. So now it is separable, right? So it is separable. So we can collect u terms to one side, x term to the other side. So it is a separable one. Now we just integrate. What is the integral of sine u? It is minus cosine u. I will write. And we have ln x plus c. But don't forget to put y over x back. So cosine y over x is equal to ln x plus. So you can leave the equation like this. So if you want to simplify more, I mean, you can do many things. But this is enough, I think. But sometimes instead of c, sometimes we write ln c also to simplify it more. But we can leave it like this. Good. Okay, let's solve one more example. For example number 4, so it is solve y prime is equal to e to the power y over x plus y over x. So this is already, in homogeneous form. So it is a homogeneous differential equation, and we will let y over x to be u. So y is equal to xu, and we take the y prime. So, which is product rule. The derivative of x is 1. 1 times u plus x times u prime. And then we will substitute these in the equation. So we have y prime is equal to e to the power yx plus y over x. So y prime is u plus x u prime e to the power u plus u. So the u's will cancel, and we have xu prime is equal to e to the power u, or x times du over dx is equal to e to the power u. So this is a separable one, dx over x. So this is separable. We can separate u terms to one side and x term to the other side, or we can write it like this. E to the power minus u du is equal to dx over x, and then we will integrate. What is the integral of e to the power ax dx? So this integral is e to the power ax over a plus c. So this minus u over minus 1, which is ln x plus c. So we have minus e to the power minus u is ln x plus c. But don't forget to put y over x back. So e to the power minus y over x ln x plus c. So this is our solution. So the question was, solve this differential equation. Here is this implicit solution. So it is not an explicit solution. So it is an implicit solution. And c is a constant. Don't forget that. Great. I think you get the idea about homogeneous differential equations. Let me give some exercises. So exercises. First one. Okay. Let me write the question general. Solve the following homogeneous differential equations. Okay, first one is xy dy over dx is equal to 2x squared 3 over 2y squared, and dy over dx is equal to y squared plus 2xy over x squared. And the third one is x squared plus 2y squared dx is equal to xy dy 2xy prime is equal to y squared minus x squared. Great, I think this is it for the lecture 7. In lecture 8, we will study exact differential equations.